Our next speaker comes from the BioProtection Research Centre, Professor Phil Hulme, who is a Professor of Biosecurity at Lincoln University and a Principal Investigator in both the National Science Challenge and the BioProtection Research Centre. Phil.
Thanks, Travis. Okay, just a change from a bacterial pathogen that's affecting cattle to fungi affecting plants. You're probably well aware that there's increasing interest or concern regarding the spread of pathogens around the world, particularly those that are emerging pathogens we've not seen before. And unfortunately, the data that we have globally on the rate at which pathogens have been spreading around the world is fairly limited. Data from this paper that I worked on with a number of European colleagues shows that over the last 150 years, there's been a general increase in the global spread of fungi around the world. And of course, with that comes biodiversity, but also economic impacts to the countries concerned. New Zealand, of course, isn't immune to fungal pathogens, and our crop systems are particularly badly affected by a range of different pathogens, including botrytis on grapes, costing about 15 million a year to manage. Dothostroma, about 20 million a year to manage. And stripe rust, wheat stripe rust on wheat, not surprisingly, reduces yields of susceptible cultivars by about 60%. So pathogens have a major economic impact on our productive sectors. But what we don't know, and not very well, is how the number of pathogens, fungal pathogens, have been changing over time. Are we getting better at managing these, or are we, rather like the rest of the world, increasingly seeing more and more pathogens coming into our country? So what we wanted to do is to assess the long-term trends in fungal pathogens arrival and discovery in New Zealand, and then identify whether there are any general temporal trends in different sectors of the productive economy, the horticulture, agriculture, and forestry. And to understand whether the patterns are showing an increase, a decrease, or some other trend that might indicate improved biosecurity measures or breakdown in our biosecurity measures that allow these pathogens to come through. So one of the great things about working in New Zealand is that because of our relatively short European history, since European colonization, there's been a detailed record of most pathogens and pests that have been introduced, and this is particularly true for fungi. So we have records spanning over 150 years of fungal pathogens on their hosts in New Zealand. And a lot of this information is captured by the Fungi 2 database, which is managed by Longterm Research. And you can see they've got quite a few records of pathogens in the fungal and disease collection, and also drawn from the international collection of microorganisms from plants, and also the published literature. So we used the Fungi 2 database, and we also collected our own data from Kew Gardens to build the most comprehensive database we could get on fungal pathogens and their hosts over time in New Zealand. This wasn't a trivial task. We had to clean a lot of the data because there are a lot of synonymies, etc., between both the pathogens and the host. So that took quite a bit of time. And so we had to filter the database to include only pathogens. We did find there are some strange things in that database that I'm sure our archivists don't want to know about, but we filtered it down to fungi and broadly oomycetes and also plasmodiaphorids. We excluded hosts of fungi that couldn't be verified to species level. And also we wanted to know the difference between native and non-native hosts, because we were particularly interested in our crop systems. And also whether the pathogens had come from New Zealand or whether they came from overseas. Now, this is a schematic of what the database looks like. The first thing you'll notice is that in that database, most of the records are for what they call alien hosts, so species of plant that have been introduced into New Zealand and the pathogens that have also arrived in New Zealand. There's actually relatively little, by comparison, of native data. And we've been working with this database for a while, once we spent all this time actually cleaning it and curating it. And we've published a recent paper looking at these interactions where native hosts are colonized by alien pathogens and vice versa. And I'm not going to talk about that today. I am going to talk a bit more about this particular area. So the interaction between alien pathogens, alien fungal pathogens, and the alien hosts, which in this case are crop plants. And we only included in this analysis those records for which we had at least 10 records for the ADN number, that a host had at least 10 fungal pathogen records. So we filtered the database quite a bit. However, before launching into this, we've got to be really careful because there are some various pitfalls that you could actually fall into quite easily. The first is sampling intensity. If you look at New Zealand sampling intensity, you can see that it really reached a peak in the 1980s, and since then, the number of fungal records being collected in New Zealand has declined. So that can lead to a bias. We might expect things to be getting much better, but it's simply a reflection of lower investment in taxonomy. The other aspect is that the more you study a species, not surprisingly, the more fungi you tend to find on it. And so we've also got to factor out the effort that's been put into looking at the number of fungi on plants. So we have to control for this, and often it's not done. And so by doing this, we get rid of some of the biases that haven't been actually taken into account in the global surveys. The next step was actually to build a model that tries to capture two processes. One is the rate of arrival of pathogens, fungal pathogens, into New Zealand, and the other is the rate of discovery. And I'm not going to go into great detail, mainly because Richard Duncan is in the audience and he did it, and he'll only laugh at my general poor description of what he did. But basically, it actually uses the information that we have here in terms of survey effort, as well as the number of new pathogen records coming into the country, pulls those together in a Bayesian framework to try and predict both the rate of arrival as well as the probability, if something arrived, that it'd be discovered. So the next slide is going to be our first result. Now, we've all been using these smartphone apps, but I don't believe in smartphones. So if those of you think things are getting worse, could you put your hands up? So is the rate of pathogen entry into the country getting worse, or is it getting better? So those who think it's worse, it's getting worse. Okay, so we've got the afternoon pessimists are all here in the audience, okay? Well, what do we find? Well, actually, it doesn't look too bad in some respects. Remember, this is the rate at which species are coming in. This is not the total number. So this is the rate at which they're coming in. So they're still coming in, but over time, the rate has slowly declined. Now, just to point out, these kind of gray bars indicate the uncertainty we have with that estimated line. And you can see as we progress, we have fewer and fewer data, so the uncertainties are higher more recently. But this is the best fit line to that data, suggesting that over time, things have got, at least the rate has slowed, which is probably quite good news. Now, is that because we're running out of potential pathogens and that actually what we're doing, we've got everything already? Or is it something more positive, such as we're actually preventing things from coming in? For the first one, we looked at for a number of species, we looked at the total global pathogens that are found on those species, and actually New Zealand has about a third of them. So there's still plenty of scope for more pathogens to come into the country, unfortunately. So it's not that we're saturating. What it does seem, and this might be a rather biased view, and I'm not being paid by MPI, I should point out, but if you look at the inflection, it does seem to coincide with the 90s, which is when the New Zealand Biosecurity Act was introduced, but also relates to when the International Plant Protection Convention actually became the standard-setting body for the WTO. So at that time, people became much more aware about trade and potential risk of fungal pathogens being moved around. So that's only an indicator, but it does seem to fit quite nicely to potentially biosecurity measures working reasonably well in New Zealand. It's not stopping things, but it's reducing the rate at which they're arriving. So then we looked at a number of different crops. Oh, sorry, no, what I should say is what we've also got to bear in mind is over that time, while things have plateaued, trade has increased astronomically. And so if we look at the data in terms of number of pathogens per $1 million of imports, actually, given the pressure at the border, what New Zealand is achieving is pretty remarkable. In fact, the number of pathogens per $1 million of imports is a tiny fraction of what it was in the 1960s. So given the greater pressure, this kind of plateauing is pretty impressive. So different crops, well, let's look at both the fruit trees and the arable crops. We see a similar kind of pattern. In fact, for arable crops, probably even better, a sign that the rate is actually declining over time. And you can see an example of a crop here. This is cucumber. Here's some pathogens that are particularly important on this species. And for this species, individual species data shows that the rate has more or less been the same for a long while, suggesting that, at least for that species, things are being well managed. So to upset Bill Dick and other foresters in the audience, then we can look at what's happening with forestry pathogens. Somewhat of a different picture. And in fact, this pattern here more or less mirrors the rate of increase of merchandise trade in New Zealand. It seems really as if pathogens are coming in with imported goods, and probably coming in with things such as wood for packing cases, etc., since the major phytosanitary measures were only, for dealing with wood packaging, were only introduced relatively recently. So it suggests that for forestry, things aren't as good as we might expect. And we can look at one of our favorite forestry trees. If you're a forester, then you can see that for Pinus radiata, there's been a steady increase in the rate at which pathogens have been entering into the country. So not particularly good news for pathogens. So you can't stand up here and talk about fungal pathogens without talking about one particular pathogen that's on everybody's mind at the moment, myrtle rust. Now, as we all know, myrtle rust was blown over here from Australia, we assume, and a lot of rusts have come across from Australia. So would we expect biosecurity measures to have any impact on the rusts? Now, if it did, if rusts also declined in the 1990s, it would suggest that probably it's not something happening at the border, it's something else. And what we find is actually rusts have been more or less unchanged over time. There's been a continual rate of entry into New Zealand of rusts. And of course, there are a number of rusts that have come over from Australia: poplar leaf rust, willow rust, wheat stripe rust, antirrhinum rust, blackberry rust, and now myrtle rust have all been blown over. So talking about crazy things, which I think we're supposed to do, I think the crazy thing would be to actually start charging Australia for their poor biosecurity efforts that are giving us these problems, really. I mean, if we could do that, that would be a good move. So to summarize, I think we need to be positive. I get, MPI always get a bashing that whenever there's an incursion, but we tend not to have the long-term picture of how things are changing. And what we do see is that while they're not preventing things from coming in, the rate at which things are coming in is slowing down, and for some groups, actually declining, all bar the exception of forestry. And it seems as if this is linked to things like improved import health standards, for example, and better phytosanitary measures. So I think it's a generally good news story, but hopefully we can actually see those curves in the future decline. But that will require quite a different approach to what we're adopting probably today. Thank you very much.
Questions for Phil? Just Maureen? Maureen, behind you.
Thanks, Phil. That was really interesting. I guess the question I had, I think you mentioned earlier about the global spread of fungus being more prevalent. How does that relate, do you think, given that with the exception of pine, we're still getting a reduced rate, and even though global trade and travel and those things are moving around more?
So why the rate is slowing down when we've got all that trade?
Yes, so I guess, are you saying that we have greater global distribution of fungi and yet we're still slowing down the rate of entry to New Zealand?
So exactly. So the global pattern is that for most other countries, if we had this kind of data for other countries, we would not see that kind of decline. So in that first paper, New Zealand stands out for a variety of reasons. If you look at the plant introductions, so weed introductions, New Zealand also plateaus, whereas other countries are still going up, and that's because of our biosecurity measures. And so I think the same is true for pathogens, in that the biosecurity measures, the stringent import health standards that are being applied are having an effect, and that's why. And maybe in Australia we'd see a similar pattern where they've also got similar stringent approaches, but I suspect in other countries it's not so clear.
There was a question over here.
Just for clarification, did you also consider lags between actual arrival and detection in your data and analysis?
Yeah, well, I mean, that's the idea, is that the probability of being discovered will vary over time. Exactly. Yeah, so
Oh, I mean, like, when you say the Biosecurity Act 1993 had an effect in the following years, like, presumably if there's a lag between the actual arrival and the detection, you would have to wait for at least a number of years until you see any effect of that?
Yep, no, that's true. And if you look at the plateau, it's not a peak, it's a broad area. And so that's why it's not necessarily just the Biosecurity Act. I think it's the 90s might have shown a shift in the way that we're managing imports. But again, with pathogens, I wondered how long the lag is for some of these pathogens. Things like myrtle rust, what was the lag for that? I don't think it was very long. So, you know, it's for some of these pathogens, I think the lag is short enough that the date could be quite, relatively precise compared to plants, for example.
A last question, Bill?
Yeah, thanks, Phil. So do you think the border's biased against forestry? And, you know, perhaps, you know, when you come through the border, what do you get checked for? You get checked for apples and meat. And if they happen to find pine needles with your golf clubs, MPI takes your golf clubs away and cleans them for you. Whereas if you're found with an apple, they find you $400. So maybe it's this border bias that's resulting in more pests coming in for forestry. What do you think, Christine?
Well, I think to some extent soil is an important thing that's coming in. I don't think there's necessarily a bias, but obviously soil is thing. I think probably the problem is foresters who are coming in from overseas and they don't clean their boots, and then the next thing they're doing is going onto their plantations. But you probably might know a bit more about them than I do.
Okay, thanks, Phil.